project is to allow the driver to gain a greater awareness of their surroundings while still maintaining their awareness on the road. We do this by projecting an image onto the windshield of the car containing information such as miles per hour, RPM, or engine temperature.
One of our design considerations was where to get power from. We decided to go with two different sources for this project. The first source was an OBD2 port. This port is standard on every car since 1996. It's located right beneath the driver's seat, and you plug in and it has a 12-volt rail. This line is fused with the cigarette outlet, and it can supply more than enough current. We use diode protection on these lines to make sure that the voltages would not get too high, and also to make sure that the current would not flow the wrong direction. Our second power source was a cigarette outlet. We used this source in case there was a problem with the OBD2 port, or if the car did not have one. The cigarette outlet can also supply enough current, and is also diode protected. We installed an on-off switch on the box to make sure that we could turn the power off if needed if the car did not control the supply. One of the hardest decisions for this project was what type of display to use. We went through many considerations for this, and it caused us some challenges. The first consideration we had was projection. We got a home projector actually, and took it in my truck, and we tried it out, and it completely washed out in the sun and in the night. We used tents, some really dark tent, tried to project it on the tent, and it would just be completely washed out. Our second option was to use a VFD display. This display is really cool because we could do some better animation on it and have cooler graphs and a nicer display. And we actually tried it out in the car. It worked really nice when it was a cloudy day, but as soon as you got out in the sun at all, it would just completely wash out. Not even reflecting it. When we're just looking at this way, it'd be washed out. We also considered a laser display. The laser display we ruled out just because of safety reasons. We'd be shooting it at the windshield. It could shoot through the windshield, or it could reflect in someone's eye, shoot through and hit someone else across the street. We just thought it wouldn't be a safe option. We finally decided to use an LED dot matrix display. The one we found had super bright LEDs. We were able to test it. We tried it out in the dark and the light, and it works well at nighttime, and it also works well in the daytime.
Our GPS module was donated by Garmin. It comes with a flimsy little testing connector on it that they suggest you cut off and replace with something more durable. We chose an Ethernet connector for its easy availability. It plugs into our board, and it talks with a serial protocol. And our AppMega does handle serial, but our scan tools chip also talks over serial, so we chose an I2C bridge that converts the serial to an I2C protocol, which then is handled easier by our chip. So this is our board installed in the bottom of the box. Here we have our microprocessor, the AppMega 328, and this is the I2C chip that does the translation between the GPS, which comes in over the Ethernet connector, and then talks to the microprocessor.
This is the OBD2 protocol cable. Every car made after 1998 has this tip. It's normally located underneath the steering wheel on the driver's side, and it plugs in, and it sends all the communication lines, the 12-volt power feed, the chassis ground, and the signal ground through the cable to the other end. This side plugs into our box, and we have the pinouts that match it, and we can pull the signals we need from it and get power from the car. The level shifters take these high voltages and move them down to more logic level that are safe for our microcontroller. From the voltage shifters, we move to the scanning tools chip, which is an STN1110. This chip takes these multiple protocols and converts them to UART that the microcontroller can understand. power supply had to be able to take voltage from the car's serial outlet or the OBD2 port. This was a nominal 12 volts, but ranged from 10 volts to 16 volts, depending on what the car was doing and the output of the alternator. To do this, we took the 12 volts from the car and ran it through a TPS 5430. This is a Texas Instruments buck converter. It takes the 12 volts and regulates it down to 5 volts. You can supply 2 amps while doing this. We then used a TPS 7633 to take the 5 volts and drop it down to 3.3. The second chip is an LDO and can supply 500 milliamps of current.
For our projection system, we decided to implement an LED display. This particular LED display is a 32 by 16 dot matrix LED display from Sure Electronics. Here we have 4 quadrants consisting of 2 segments each, and they are controlled by 4 HT1632 chips found here, 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 and here. In order to have a proper GUI system, we decided to implement a user interface through the use of this rotary knob. We would be able to turn it left and right in order to choose which we want to display, and press it down in order to make our selection. For our project enclosure, we decided to have it custom made through OSU 3D printing. We used a program called SolidWorks to generate the proper files. This is our project enclosure. We have it in 2 separate pieces, one containing the LED display, the other containing our power supply and microprocessor. My message for next year's seniors is to choose people who you can work well with, preferably people who you have history with, worked on previous projects with.
If I can recommend anything to next year's seniors, it'll be get stuff done on time and early. Work really hard fall, winter term, and just knock everything out, and you don't have to worry about doing all-nighters and all the stress that comes later during checkoffs. Just double check everything, get it done early, and just work hard at the beginning. It'll pay off later.
Thank you.